integration review. We've already done this stuff before, but it's been a while since we've seen it. I do want to take some time to go over a few rules. First of all, the integral of 0 is a constant, because remember, derivative of any constant is 0. We're working backward. Integral of a k, any number, is that number times x plus c. Don't forget, we always have to put plus c. Our general power rule is that the integral of x to the nth power dx is x to the n plus 1 power divided by n plus 1. And then we have to put a plus c again at the end of our integral, because there could have been a constant. The last two listed here are just some basic properties. If we have a number times a function, we can take that number out front of an integral. That can be useful when you're trying to simplify things down, or when you're using integral properties to evaluate something. And then last, integral of two things added or subtracted. You can take the integrals separately and then add or subtract those integrals depending on what sign was in between. Now, notice that that is not for multiplication. That does not say if f times g, that you can take the integrals separately and then multiply those. You cannot do that. That does not work. This is only for addition or subtraction. Okay? Let's take a look at some review problems. Let's start with some basics, just some indefinite examples. We have 3x to the fourth. Take the integral. 3 is just a constant. Integral of x to the fourth is x to the fifth over 5. 5 is a constant. Integral of x squared is x cubed over 3. And integral of negative x, okay, negative 1 is like our constant. And then integral of x, x is to the first power, that becomes x squared over 2 plus c. This would be our final answer. We don't have to worry about common denominators or anything like that. Number 2, one thing we would want to do is rewrite this. Instead of square root of x, we would write that as x to the 1/2 power. Take the integral, x to the 1/2 becomes x to the 3/2, and then we would divide by 3/2, which means we're going to flip and multiply by 2/3. So we would have 2/3 x to the 3/2 plus c. All right, fundamental theorem of calculus. This is what we call definite integrals. Remember the difference with a definite integral or using fundamental theorem of calculus, which we can abbreviate FTC, are our limits of integration. Okay, so if we're taking an integral from a to b, we want to plug b into the integral first, and then plug a into the integral, and then subtract. So let's take a look at what that looks like as a refresher. Third example here, integral of x cubed minus 3x plus 1 from 1 to 2. Okay, so integral of x cubed is x to the fourth over 4, minus 3 is a constant. Integral of x is x squared over 2, plus integral of 1 is just x. And remember, we have this vertical bar that signifies, hey, we got to plug these things in. This is definite. So let's plug in 2 first. Okay, we got 2 to the fourth over 4 minus 3 times 2 squared over 2 plus 2 minus, plug in 1. We love when we have 1 because that's so easy. 1/4 minus 3/2 plus 1. All right, 2 to the fourth is 16 over 4 is 4 minus 2 squared is 4 times 3 is 12 over 2 is 6 plus 2. Uh-oh, take a look here. 4 minus 6 plus 2 all cancels out. That's gone. So we have a negative. Let's get a common denominator, make it a little bit easier. 1/4 minus 6 over 4 plus 4 over 4. 1 minus 6 is -5 plus 4 is -1. So we end up with -1/4. Oops. Sorry for that interruption. We had a negative out front. Negative -1/4 becomes positive 1/4. Okay, let's try number 4. Integral of 3 square roots of x. Again, we would want to rewrite that as 3x to the 1/2. Okay, so let's think about taking that integral. oops, actually I don't need that anymore. We have 3 as a constant times x to the 3 halves divided by 3 halves, which means multiplied by 2/3. 3 over 3 cancels, and we now have 2x to the 3 halves, and we're evaluating at 4 and 1. We want to plug in 4 first. So 2 times 4 to the 3 halves minus 2 times 1 to the 3 halves. Remember, with our fractional exponents, you can do the bottom part first, take the root first. So square root of 4 is 2, and then raise that to the 3rd power gives us 8. We have 2 times 8 minus 2 times 1. 1 to anything is still 1. So we have 16 minus 2, which gives us 14 for this definite integral. All right, let's keep going. Here's another way that we can use integration. Let's say they give us an expression for f prime of x and an initial condition. This would be our initial condition. We know f of 1 is 4. What this allows us to do is actually solve for the c value. So we know that f of x would be the integral of f prime, which is 3x squared minus 1 dx. So now, if we try to take that integral of 3x squared, x squared becomes x cubed over 3, and we're multiplied by 3, so we just have x cubed. Integral of negative 1 is negative x, and we need plus c. Now we know that f of 1 equals 4, so let's plug in 1. 1 cubed minus 1 plus c. 1 minus 1 cancels, so we know that 4 is our c value. So we know now that f of x is x cubed minus x plus 4. Okay. Let's also talk about a very big piece, which is trig. Just a quick reminder of our trig integrals. Excuse me. So integral of cosine is sine. Integral of sine is negative cosine. Integral of secant squared is tangent. Integral of cosecant cotangent is negative cosecant. Integral of secant tangent is secant. Integral of cosecant squared is negative cotangent. So let's take a look at using these. Oops, I skipped ahead. Here we go. Let's take integral of 2x minus cosine of x. Integral of 2x is just x squared, I could write. And integral of negative cosine is going to be negative sine of x. And then we need plus c. Remember, you can always take the derivative really quick to make sure it works. Derivative of x squared is 2x. Derivative of negative sine is negative cosine. All right, next one. We don't really have, well, we could actually do this one with substitution, but we could also simplify it down to begin with. Let's say we simplify this to be cosine over sine times 1 over sine. That's equivalent. Then cosine over sine is cotangent, and 1 over sine is cosecant. And we know that the integral of, excuse me, cotangent cosecant is negative cosecant. All right. Oops. Let's try one definite example. Integral of 2 minus sine of x, and we're going from negative pi to pi. Integral of 2 is 2x. Integral of negative sine of x is positive cosine of x. We put in our limits, so let's plug in. First, we want to plug in pi. So we have 2 pi plus cosine of pi minus, plug in negative pi. We have negative 2 pi plus cosine of negative pi. Okay, let's simplify down. 2 pi minus 1 minus negative 2 pi minus 1. Okay. Notice we have -1 minus -1. That's going to cancel out. 2 pi minus -2 pi becomes 2 pi plus 2 pi, which is 4 pi. All right, next thing that we're going to take a look at is integration by substitution, which we also have already learned, but I want to go back over. We still end up using a lot of our same rules. We just have to be sure to, oops, wanted to write something before we went on. If we have the integral of u to the nth power du, remember this is our general power rule, we end up with u to the n plus 1 over n plus 1 plus c. Big thing to remember is that we have to take into account, we have to have our du. So we have to have a version of the derivative somewhere of u. Let's take a look. Look at this first question here. Okay. Usually your u is, with u substitution, is whatever is more complicated in the function, whatever is inside a square root, whatever is inside a parentheses. It really just depends. Maybe it's on the bottom of a rational function. So let's take a look at this first one. Sine over square root of cosine of x. I take my u, cosine of x, then my du would be negative sine of x because that's the derivative of cosine of x. Now, we can rewrite this in terms of u. So square root of cosine x being on the bottom, that's square root of u on the bottom, which is u to the 1/2 on the bottom, which if we brought to the top is u to the negative 1/2 power. Then we're still left with sine of x dx, which is the negative, so the opposite sign of our du. So we have negative du. All right, let's take this integral now. We still have a negative. Integral of u to the negative 1/2 would be u to the 1/2 divided by 1/2, which is the same as multiplying by 2. And then we need plus c. Let's plug back in our u. That would be -2 times cosine to the 1/2, which is the same as square root of cosine of x, plus c. All right, let's do the same over here. Take a look. We can't take this integral as it is. So inside our square root is probably what's going to be our u. Let's try that out and see if it would work. If 2x cubed minus 5 is our u, then our du, take the derivative, would be 3x squared dx. Then let's rewrite this in terms of u. So we have all of this underneath the square root is our u under the square root, which is u to the 1/2. 3x squared dx, which is left, is our du. So integral of u to the 1/2 is u to the 3/2 divided by 3/2, which is multiplied by 2/3 plus c. Now let's plug back in our u. 2/3 times 2x cubed minus 5 to the 3/2 plus c. One more example. Actually, two more, excuse me. These are definite ones, so let's take integral of cosine of x over 2 from 0 to pi. So your u is over 2. Think about du would be 1/2 dx, derivative of x over 2, which is the same as 1/2 x. Now, we have cosine of x over 2, so that part is cosine of u. Now, du is 1/2 dx. We have 1 dx, so we actually have 2 du. Let's take the integral of 2 cosine of u, excuse me, integral of 2 cosine of u to sine of u. Now let's plug back in the u. Oops, we don't need the integral anymore. So 2 sine of x over 2, and we're going from 0 to pi. Plug in pi first. 2 sine of pi over 2 minus 2 sine of 0 over 2, which is just 0. Okay, we should know our trig values. Guys, remember AP exam, 2/3 of the AP exam is calculator inactive. You have to know your trig values. Sine of pi over 2 is 1. So 2 times 1 is 2. Minus 2 times sine of 0. Sine of 0 is 0. 2 minus 0 gives us 2 for that one. Okay, let's try this last one. Before we can try to do any kind of evaluation, we got to take the integral using substitution. If our u is what's inside the parentheses, x cubed minus 2 du would be 3x squared dx, derivative of that. Let's rewrite in terms of u. So all of this to the third power is u to the third power. And then we have x squared dx left. So we have 1/3 of the du. Let's take that integral. 1/3 is just a constant. Integral of u cubed is u to the 4th over 4. Okay, we don't need the plus c because we're definite. Let's plug back in. So 1/3 and then 4 is on the bottom, so we'll make that 1/12 times u to the 4th. So x cubed minus 2 to the 4th power. I'm going from 0 to 1. Okay, if we plug in 1 cubed minus 2 is -1 to the 4th power is 1 minus 1/12 times 0 cubed is 0 minus 2 is -2. -2 to the 4th is 16. So let's see what we got. 1/12 minus 16 over 12, which would be, excuse me, -15 over 12. If we reduce that, divide by 3, so -5 over 4. Our final answer there. Okay, guys, I hope this has been a good review of all our integration techniques. We already learned these, but this has been an overview of the integration techniques that we learned in Calculus Honors.